Yesterday class, yes, interpreter and compiler, the differences discussed. Let me open document.
है message symbol.
Yes, this is our document.
Okay.
So 1 second. Yeah, this 1 second. This app, some little bit version changed. This version don't have the option mute everyone. Okay. Yeah, let us start. Okay. So let us start. So yesterday discussed about all this introduction. Yesterday all this introduction completed. Yes, interpreter compiler the difference completed. Today about Java. Let us start Java. What is Java? Java depends on compiler or interpreter. Let us see. First, let me explain what is Java, how Java is working. Let me explain about Java. So once explained about Java, then you answer it. You decide it. I will explain. Yes, you decide it. Yes, Java. Yes, let us see about Java. About Java. I request everyone to mute from your side. I request everyone to mute from your side. I request everyone to mute from your side. Yes, here don't have the option mute all option don't have. Here this app don't have the mute all option. I think actually this will not start actually. It has to start actual version only. But yes, maybe this is online team mistake. It was a mistake from the online team. Okay. Java. See Java, except Java in other languages. In other languages, except Java in other languages. Yes, maybe C language or C++ or Python. Any case. So
Sir,
first of
your
all,
screen is not visible.
my screen not visible.
No, just it gone. Like just 2 seconds ago, it gone.
Yes, guys. Can you see my screen? See this my Word documents. Yes, I'm typing in Word. I'm typing in Word.
Yes, now it is visible.
Do one thing. Here it's a option called hide everyone option is there. Yes, I request everyone select hide everyone. Here view everyone, hide everyone is there. Yes, hide everyone. Select this option. See, Yes, in your ramp, there is a hide everyone option is there. We can hide it. So you can see very clearly. Hide everyone option is there. You can see very clearly. Okay. Yes. Now see Java. See, except Java in other language, what happens? First of all, source code, maybe C program or Python, something like this. Source code converts into binary code. Source code converts into binary code. That binary code given to processor. Binary code given to processor. So processor taking binary code, then executing, generating output. This is what is happening with other languages. This is what is happening with other languages. So this is what is happening with other languages. Okay, source code converts into binary code. That binary code given to processor generating output. Okay, processor generating output. Processor generating output. Fine. Processor generating output. So this is what is happening with other languages. Okay. Yes. Now come to Java. In Java, what happens here? In Java, so first of all, source code yes converts into byte code. This is a byte code. Source code converts into byte code. Source code converts into byte code. That byte code converts into binary code. Binary code. That binary code given to processor. Given to processor. Given to processor. So processor taking that binary code generating outputs. That's it. Now what is happening here in Java? So another code introduced, byte code introduced in Java. Okay. See in other language except Java. See except Java in other languages. Except Java in other languages, what happens here? Source code directly converts to binary code. Source code to binary code. Yeah, this is either interpreter or compiler. Only one thing here. Either interpreter or compiler. Either interpreter or compiler converts source code to binary code. That binary code given to process generating output. Yes, if it is Java, yes, two steps. Other language only one step. Source code directly converts to binary code. Okay, but when come to Java, there are two steps here. There are two steps. Two steps. First, source code converts to byte code to binary code given to processor. Okay, so byte code. Yeah, there is a intermediate code introduced in Java. Okay, some intermediate code introduced. Okay, some intermediate code introduced in Java. So why that intermediate code introduced in Java? So why that intermediate code introduced in Java? Okay, yes, some intermediate code introduced in Java. So why? Yes, to make this Java as independent platform. Byte code. Yes, byte code. Why this byte code introduced in Java? To make this Java as independent platform. Yes, today topic. Today the topic only we'll discuss. Independent platform topic today we'll discuss. Okay, source code to byte code. Yes, byte code to binary code. That code given to processor generating output. Okay, yes, who will convert source code to byte code? Now, source code to byte code. This is by this Java compiler. Java compiler. This is by the Java compiler. Okay, next byte code to binary code by the interpreter. Yes, byte code to binary code by the Java interpreter. Java interpreter. Java interpreter. Java interpreter. Okay, Java interpreter. Okay, so here, so first the source code to byte code by the Java compiler. Source code to byte code. Source code to byte code by the Java compiler. Byte code to binary code by the Java interpreter. Okay, fine. Let us see some practical example. Some D drive, some test folder. Here, some Java program file is there. Okay, yes, test D drive test folder. D drive test folder. Yes, command prompt. Opening command prompt. At the command prompt, D colon that will take to D drive. D colon will take to D drive. DR output now test directory. Test directory. CD test change of directory. CD test. CD test change of directory. CD test change of directory. CD test. So change of directory changed. Directory changed. Okay. Yes. Here's directly changed. Now CLS clear the screen. DR. Now here they say test.java. Test.java. See notepad. Notepad. See. I'm here understanding purpose. I'm using notepad. Understanding purpose. I'm using notepad. Understanding purpose. I'm using notepad. Notepad. Okay. Understanding purpose. Just I'm using notepad. Notepad. Okay. Actually, we'll be using Eclipse. Yes. Everyday class. Everyday class. Yes, everyday class. Everyday class using Eclipse only here. Daily class Eclipse. Eclipse ID. Just today only understanding purpose I'm using Notepad. Understanding purpose Notepad. Notepad test.java. Notepad test.java. Yes, open here. Test.java. See here some program something like this. Public class test. Okay, public static void main. Okay, hello world program. Simple is Java program. Save. Save and exit. Not dr cls. This is your Java program. Test.java Java program. First you have to compile it. This program has to compile Java C test.java Java compilation. Yes, compiled. Compiled. After compilation, dr series. After compilation. After compilation. Now see this tested dot class file generated. Java C. So Java C after compilation tested.java Java C Java test.java compiled compiled. Yes, after result is tested.class. See the time 9:20 p.m. Yes, date 30/12. So 30/12, right? Yes, 30th December 9:20 p.m. At this time test.class file generated. It's a timestamp. That file timestamp. Okay, now test.class file generated. Yes, after it Java test enter key. Yes, hello world, right? That's it. Okay, so there are two steps, right? So two steps. First step is compilation process. Java C test Java compilation. Yes, after compiling, next running Java test running. That's it. Hello world. Okay, Java C. It's a Java compiler. Yes, here errors checking with the Java compiler. If no errors, generating dot class file. Okay. Yes, here see, source code to byte code by the Java compiler. Source code to byte code by the Java compiler. Okay, here Java compiler, Java compiler check for yes, check for checks Java compiler checks for errors, checks for errors, checks for errors from top to bottom, from top to bottom, from top to bottom, from top to bottom. Yes, if no errors, if no errors, then generates dot class file. Dot class file means byte code file. It's a byte code. This is called a byte code file. It's a byte code file. It generates yes byte code file. Byte code file generates byte code. That's it. Byte code file. Okay. So Java compiler checks for errors. Okay. Java compiler checks for errors from top to bottom. From top to bottom. If no errors, then it generates dot class file. Yes, here is like this. See, test.java test.java file is given to Java compiler, Java C compiler. Java C compiler generating one dot class, test dot class. See, test.java. This is source code. Test.java contains source code. It is source code. Okay, so test.java contains source code. The source code file is given to Java C. Java compiler checking for all errors. Yes, if no errors, then it generates dot class file. So generates dot class file is a byte code file. Byte code file. It's a byte code file. It's a byte code. It's a byte code. Okay. Yes. After that, so byte code file. Yes, byte code file. This byte code file given to Java interpreter, Java interpreter, Java interpreter, Java interpreter, Java interpreter. This is given to Java interpreter, Java interpreter. So byte code file given to Java interpreter. Okay, a Java interpreter. Okay, that converts into binary code. That converts into binary codes, and given to processor. Then finally generating output. That's it. Okay. See here, first step, first step. Java C test.java compile, right? Java C test.java. So test.java file given to Java C compiler generated dot class. It's a byte code file. Byte code file. dot class got it, right? After getting dot class here, after getting dot class, now dot class for execution. Okay, Java tester. Now this is interpreter. Interpreter taken dot class file. Java sim Java compiler. Java compiler taken test.java generated one dot class file. Java compiler taken test.java. So you get test.java. Test.java given to Java compiler. Okay, compiles, no error, generating one dot class file. That dot class file now dot class file given to interpreter. This dot class file given to interpreter, Java interpreter. So dot class file. So dot class file. Yes, this dot class file. Yes, given to Java interpreter. Okay. Now Java interpreter taking dot class file here. Yeah, the dot class file converting to binary code line by line conversion and given to processor. Then yes, generating output. That's it here. Okay. So what happens here? Yes, in Java compiler checks for the all the errors. Okay. Yes, here in Java what happens here? Yes, compiler checks for errors. 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 Next, program execution. Yes, runtime. Yes, runtime. Runtime program execution. Program execution. Execution. Execution by the interpreter. Program execution by the interpreter. Interpreter. Program execution by the interpreter. Okay. Yes. So error checking by the compiler. Okay. Error checking by the compiler. So compiler check for all errors. If no errors, program runtime program execution by the interpreter. See this. So first compiler part, next part interpreter part. Okay. So first compiler worked. If no errors, then given to interpreter. Interpreter executed. That's it. Interpreter executed. That's it. Now Java depends on what? Is it interpreter or compiler? Tell me guys. Java depends on what? Yes. Is it interpreter based or compiler based? Java depends on what? Is it interpreter based or both here? Java depends on what? Is it interpreter based or compiler based? Yes. Now, as per this explanation, yes, explain very clearly. Now, we decide it. Is it compiler based or interpreter based? Yes. Someone is sharing the chat box, but I'm able to. Okay. Fine. Yes. Depends on what? Yes. Yes. Depends on both. Depends on both. Yeah. Yeah, Java depends on both compiler as well interpreter. Okay, first compiler involving, next interpreter involving. Java depends on both compiler as well interpreter. That's it here. Okay, yes, depends on both Java depends on both compiler as well interpreter. Java depends on both here. Compiler as well interpreter. That's it. That's it. Okay, yes. Next here, some question for you guys. Some question. Yes, in yesterday topic. Yes, in yesterday topic. In yesterday topic, some point we have discussed. See, in yesterday topic, some point we have discussed. Interpreter based language don't have the exe file. Interpreter based language don't have the exe file. Interpreter based language don't have the exe file. Okay, see, any language, any language, any language, runtime is an interpreter based. Any language runtime is an interpreter based. Don't have exe file. Suppose Python runtime is interpreter based, no exe file. Okay, HTML coding, interpreter based, no exe file. Okay, next Linux shell scripting, no exe file. So those cases, no exe file. Okay, next about Java here, about Java. See, yes, in Java Java language, runtime, is an interpreter based. Java language, see this. Java language runtime is an interpreter based. Is an interpreter based. Now question. Question for you guys. Question for you guys. Question is, question is, question is, yes, is there any exe file concept in Java? Is there an exe file concept in Java? Or can we create exe file in Java? Can we create exe file in Java? These are questions here. Maybe asking question like this or like that here. So is there a question is there an exe file concept in Java, or can we create exe file in Java? That's a question. Yes, anyone can you answer this? See here, any language runtime is interpreter based. Any language runtime is interpreter based. Don't have exe file concept. Any language runtime, any language, any language runtime is an interpreter based. Don't have exe file concept. Java language runtime is an interpreter based. Runtime Java program executing by the interpreter. So, is there any exe file concept in Java, or can we create exe file in Java? Tell me as per this explanation. Yes, why using command prompt means explanation purpose I'm using command prompt. When come to actual programming, we'll go for Eclipse only. Actual programming will discuss Eclipse. Only one example, only understanding purpose I'm using command prompt. Okay. Now can we create exe file in Java? Question is, see, I'm repeating once again. I'm repeating once again. I'm repeating once again. See, simple, very simple, very simple. Yes, any language runtime is a interpreter based. Don't have exe file. Yes, see, any language. If any language runtime is interpreter based, don't have exe file concept. If program executing by the interpreter, no exe file concept. Yes, in Java language, runtime is by the interpreter based. That means Java program executing by the interpreter. Java program, Java program, yes, Java program executing by the interpreter, executing by the interpreter. Okay, you program executing by the interpreter, no exe file concept here. See, program runtime is interpreter based, runtime is execution. If execution by the interpreter don't have exe file concept, yes, you program execution by the interpreter, no exe file concept. Java program execution by the interpreter. Yes. Now question is there an exe file concept in Java? Can we create exe file in Java? Tell me. How you answer this? Still not understanding? Still not understanding? Hello. Try to understand it. Any programming language runtime is interpreter based, no exe file. Any programming language runtime is interpreter based, no exe file concept. Java runtime is a interpreter based. So is there an exe file concept in Java? Can we create exe file in Java? What's happening? I'm saying this very clearly. I'm saying what I'm saying here. See, try to understand what I'm saying. See what I'm saying here. Any language runtime is interpreter based. Yes, you program executing by the interpreter, no exe file concept. Java program executing by the interpreter. So exe file, yes, is there or not? As per that point. Okay, next one more. See here. So this is Java program here. So first step, notepad, notepad, test.java, notepad, test.java opens. This is first step, writing program. Of writing Java program, next compilation. Yes, test.java compilation. Result is dot class file generated. So dot class file generated. So dot Java file converted to dot class file. Okay. Now the dot class file executing. Dot class file executing, right? Yes. Now in this process, in this whole process, have we seen anywhere dot.exe file? Yes. Have you observed dot.exe file in this process? Yes. In this command line here, program compiled and executed. Yes. Have you observed any exe file? Have you observed any exe file? Come on, guys. See, my class are interactive classes. My training is different, others training is different. Most of the trainers they will explain their own way. Most of the trainers they will explain their own way. Okay, one way. But my way of training is interactive classes. Okay, yes, you should ask questions. I have to answer that. Yes, yes. Reverse. I'll be asking questions. You have to answer. I'll explain the concept on that concept, asking questions. Yes, Java. No exe file concept in Java. There is no exe file concept in Java here. In Java, everything is dot class file. Java don't have the exe file concept. We can't create exe file in Java here. Exe file we can't create in Java here. Okay. Yes. No concept of no concept of exe files. Okay. No concept of exe files in Java. No concept of exe files in Java. Okay, in Java. Yes, we can't create exe file in Java. We can't create exe file in Java. Okay, we can't create exe file in Java. Okay, yes, yes, in Java. See, in Java everything is dot class file. Everything is a dot class file. Everything is a dot class file. Everything is dot class file. Okay, yes, dot class file is not exe file. Dot class file, yes, is not a exe file. Dot class file is not exe file. Dot class is not exe file. Okay, see, in Java everything is a dot class file, but dot class file is not exe file. Okay, but dot class file is not an exe file. It's not an exe file. Exe file is different. Dot class file is different here. So what is exe file? Yes, exe file is a binary code file. Binary code file. Yes, binary code file. Exe file is a binary code file. Binary code file. Yes, it is a system understandable language. It's a system understandable. It's a system understandable language. It's a system understandable language. Okay, it's a system understandable language. Okay, what is dot class? Dot class file is a byte code file. Byte code file. Dot class file is a byte code file. Yes, it's a JVM understandable language. JVM understandable language. JVM understandable. JVM understandable language. JVM understandable language. That's it here. Okay. So you see here, exe file is a binary code. Means zeros funds format. Exe file is a binary code file. Yes, it's a system understandable language. Okay. Dot class file is a byte code. It's a byte code file. Dot class file is a byte code file. It's a JVM understandable language. Yes, exactly what is exe file, what is dot class file, we'll discuss. We'll discuss now. Okay. Yes. So this is Java. So Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. Okay. Yeah, that's all. Okay. Yes. See, same thing explained in document here. Java depends on both the compiler as well interpreter. Okay. In Java, errors checking by the compiler. In Java, errors checking by the compiler. If no errors, yes, if no errors, then Java compiler generates a dot class file. If no errors, Java compiler generates dot class file. Dot class file is a byte code file. Dot class file is a byte code file. Java runtime by the interpreter. Java runtime by the interpreter. See what is happening in Java. See this source code given to Java C compiler. Java compiler generating byte code file dot class file. The dot class file given to Java interpreter. Java interpreter converting byte code to binary code. Okay, links to OS library. That next we'll discuss. Today only we'll discuss. Yes, in couple of minutes this topic will discuss. Binary code and generating output finally. Okay, so what is happening here? See this. So source code convert into byte code to binary code, processor, then output finally here, right? Okay, yes. See here, source code to byte code by the compiler, byte code to binary code by the interpreter. Okay, Java depends on both compiler as well interpreter. That's it here. See, Java runtime is an interpreter based. Java runtime is interpreter based. See, any language runtime is an interpreter based. Any language runtime is an interpreter based. No exe file concept. Okay, since Java runtime is program execution. Since Java runtime is interpreter based, no exe file concept in Java. Okay, can we create exe file in Java? No. There is no concept of exe files in Java. Yes, in Java everything is a dot class file. In Java everything is a dot class file. Dot class file is not an exe file. Dot class file is not in exe file. Yes, exe file. Yes, see this. Exe file is a binary code file. Exe file is a binary code file and it's a processor understandable language. Here dot class file is a byte code file. Dot class file is a byte code file and it's a JVM understandable language. That's it. Yes, up to this discussed very clearly. Okay, so in document everything is there very clearly. Okay, yes, now let us see about this. For next topic is, yes, Java features independent of platform. This topic we should discuss now. Yes, very important and interesting this is. Okay. Sorry. Sorry. Yes, see, Java is an independent platform. Java is independent platform. Yes, what does mean? What does mean? First question, what does mean here? Java is independent platform. See, when explaining features of Java, first independent platform. So Java is independent platform. What does it mean? What does it mean here? Okay, platform means OS. Platform means OS. So what does it mean here? Java program, Java program, yes, Java program can run can run on any ways, on any ways. Independent platform. Java program can run on any ways. So that is nothing but independent platform. Yeah, that's okay, fine. Now question is immediately question here, how Java, yes, how Java made us independent platform, independent of platform. How Java made us independent platform? Immediate question. Yeah, this is important question. See, anyone says that Java is independent of platform means Java program running anywhere. Java program running on anyways, that is independent of platform. Independent of platform. Then how Java made us independent of platform? This is very important. How Java made us independent of platform? So this is important point. How Java made us independent of platform? Let us see about this. How Java made us independent of platform? Okay. Yes. For this purpose, first of all, about exe file we should discuss. Exe file, about exe file, some question for you guys, some question. Exe file prepared, exe file prepared on Windows OS, on Windows OS, can I run on Linux OS? Is a question. Yes, anyone can answer this. Exe file prepared on Windows OS, can I run on Linux OS? That's a question. Yes, exe file prepared on Windows OS, can I run on Linux OS? Exe file prepared on Windows OS, can I run on Linux OS? Can I run on Linux OS? Yes, here answer is no. No. Answer is no. Answer is no. Yes, for this answer is no. Reason. Reason. Reason is exe file. Yes, exe file. Yes, is an OS dependent. OS dependent. Exe file is an OS dependent. OS dependent. Yes, immediately question here, why exe file? Why exe file is OS dependent? Why exe file is OS dependent? Yeah, this question asking immediately here. Yes, how to answer this? Yes, why exe file is OS dependent? Why exe file is OS dependent? Yes, for this, yes, why exe file is OS dependent? What's the reason for this? For this purpose, you must have exe file knowledge. What is exactly exe file? What is exactly exe file? Okay, yes. Suppose C program, C program exe file, C program exe file prepared, prepared, prepared on, yes, Windows OS, Windows OS. Then it contains what? Then it contains what? C program exe file, C program exe file prepared on Windows OS, Windows OS. Then it contains what? It contains what? See, let us go to C program, C turbo C, C program, This is C program. C program. Yes, main function. See, math.cpp, math.c both are same. C program, C++ both are same. Now backend of this program, Turbo C. It's a Turbo C backend, Turbo C. C drive, TC, Turbo C. Yes, here bin math, yeah, math. See math. See, this is math.cpp backend file. Math.cpp. Now I'm compiling this file. So when compiling this file, what happens? Compilation. Or see, compile just only compilation. Compiled. Yes, error message. There are some errors. See errors. Here semicolon missing. Yes, here packet missing. Next scanf, here comma missing. Okay, comma missing. Yes, next here semicolon missing. Scanf semicolon missing. Yes, next here printf, here double quotation missing. Okay, next here printf. This printf. Here bracket missing. Okay, next this printf. Here semicolon missing. Yes, here this get ch bracket missing. Okay, compile. Yes, success, no errors. Success. Okay, now success. Press any key. See in the backend what happens. Let us see. See, this is math.cpp file. Math.cpp. CPP means C++. It's a C++. C++, C both are same. C++ and C both are same. Now compilation. Compile menu opens in that first option. Compile. Enter key. See, once you compile, something happens here. See this. Observe at the back end. In the back end, observe something here. Just a compilation. Yes, compile success. See this. At the back end, math.obj file generated. Math.obj means object file generated. See this. Math.obj file, that object file generated. So what is that object file here? See, that object file contains binary code of the C program. That math.object file contains this binary code for C program. Your C program converts into binary code, then write to math.yes object file. Next, apart from this, see here stdio data, coordinate data. They are the header files. These header files also having some binary codes. These header files, yes, these header files developed in C language. C language header files developed in C language only here. So behind of this stdio data header file, it's binary code. These header files also having binary codes. See, your program binary code is math.obj. So this math.obj file, this object file contains your C program binary codes. Yes, next. Yes, stdio data header file also contains one binary codes. Okay, fine. Okay, now run it. When you run this, what happens here? See, when you run it here, see application math.exe file created. Math.exe file created. When you run it here, see that math.exe file created. Yes, how that exe generated here? How? Yes, at the time of creation of exe file, what happens? What happens here? What happens? Okay. Yes, at the time of creation of exe file, C compiler taking your program binary codes, your binary code plus stdio data set of a library binary code plus OS library binary codes. By linking all these binary codes, generating exe file after execution. Okay, first it will generate one exe file. It will generate exe file. Now here C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains binary code. Binary code. Binary code for C program. Binary code for C program. Binary code for C program plus binary code for C program. Binary code for C program plus binary code. Binary code for binary code for C library. Binary code for C library. Binary code for C library plus binary code for Windows OS library. Windows OS library. That's it here. Okay, so at the time of creation of exe file here, that C program exe file links with Windows OS library. Okay, C program exe file links with Windows OS library. That exe file contains binary code for C program, binary code for C library, then binary code for Windows OS library. That means OS library linked with exe file. Okay, so exe file, yes, exe file linked with exe file linked with OS library, OS library, OS library, OS library. Okay, one second. See, in previous class we have discussed on point in previous classes. See here, in previous class, see, every program has to link with OS library. In previous class only, every program has to link with OS library before going to start execution. Yes, C program or Java program or C++ Hadoop. Yes, all the applications of these programs, all these programs, all these programs linking with OS library. Half linking with OS library, then execution starts. So every program has to link with OS library. Every program has to link with OS library before going to start execution. Yes, suppose if it is C language, what happens? At the time of creation of exe file itself, at the time of creating exe file itself, OS library linking with exe file. It's a static linking. Okay, see exe file linked with OS library. Yes, yes, at the time of generating, at the time of yes, at the time of generating generating exe file, generating exe file, exe file. At the time of generating exe file, yes, it's a static linking. It is a static linking, static linking. It's a static linking, static linking, static linking. That's it here. So exe file linked with OS library at the time of generating exe file. It's a static linking. Okay, let us see one more example. One more example. One more example. Another example. C program exe file prepared on Linux base. Linux base. C program exe file prepared on Linux base. C program exe file prepared on Linux base. Then it contains binary code for C program, same binary code for C library, binary code for Linux OS library. That's it. Let us see Linux also. Yes, C program on Linux base. C program on Linux base. Let us see about this. C program on Linux base. Okay, C program on Linux base. C program on Linux base. Let me start Linux base. Linux base. Yes, Ubuntu Linux. Yes, the demo login. Demo the login user like a Windows login, Linux also login. Yes, line is command prompt. Yes, now you can see step by step very clearly how that exe file is generating. Now you can see Linux, you can see very clearly. ls cd mn raw ls. You guys don't worry about Linux. You don't think about Linux base. Just you think about exe, how that exe file is creating. Just you observe the C program only. Don't focus on Linux. Okay. See, on Linux also you can run the Java applications. Yes, Linux environment also will discuss how to develop Java applications on Linux environment. That also will discuss. I'll explain very clearly. Okay. One second. Remove start.o. Remove star. Yes, remove T star. Yes, here this is a test.c file. Test.c file. Gedit means Linux notepad. Gedit is like a Windows notepad. Gedit, gedit, test.c. Yes, that program opens. See this. This is test.c. Okay. Now, yes, let us compile. Let us compile. Now, compile just only compilation. Compilation gcc -c test.c. Yes, compiled. Result is tested.o. So, what is tested.o? Tested.o means it's an object file. It's an object file. It's an object file. See, the tested.o object file contains binary code for your program. Only C program. Binary code for the C program. Okay, binary code for C program. See, stdio data cetera file is also having its own binary code, having its own binary codes, having its own binary codes. Okay, so test.to file contains binary code for C program. stdio data has its own separate binary code. That binary code different. This is different here. Okay, yes. Next, how for this? Next step is gcc -o. Yes, ex result ex is project test.o. Okay, now this is your program for test.o file. This is converting to exe file. That result exe is projects. Result exe is projects. Okay, enter key. See ls list of files. See project exe file generated. Green color is exe file. That project exe file generated. Now running that project exe file. Run it. Yes. Addition, subtraction, multiplication. That project exe file executed. So got the output right. So this exe file. Yes. At the time of generating project exe file, what happens here? At the time of generating project exe file, what happens? Okay. Yes, GCC means C language compiler taking binary code for your program plus binary code for stdio data cetera file and binary code for Linux OS library. By linking all of this in generates one exe file. Generates one exe file. Generating exe file. That project exe file contains yes C program exe file prepared on Linux OS. Then it contains. That means that project exe file contains binary code for C program. Binary code for C library means stdio data cetera file. Binary code for Linux OS library. That's it. Yes, let me show that. See. Project exe file. File command. This is a file command to check the type of exe file. Sorry. File is a command to check the type of the file. So what's the type of this file? File command. See this. Executable file. Project. Project is a executable file. Okay. Yet that executable file linked with Linux OS library. See, this is Linux OS library. LD Linux 8 x86 64 SO.2. This is Linux OS library. Actually, it's embedded C programming. Okay. Yes, it's the embedded C, Linux embedded C programming. In Linux embedded C, we can see all of these things. See, I'm checking the exe. The exe contains what here? The exe file contains what? Linux OS library. Linux OS library. See, you can see that exe file, gedit project. I'm opening that project exe file. Yes, open that project exe file. Yes, it's opening project exe file. That project exe file, it's opening. Yes, it will take little bit time. Exe, yes, open. See binary code, right? Zeros ones format. All this binary code. So this is exe format. It's a system understandable language. It's a binary code. This is binary code. Okay. Now this exe file is linked with OS library. That exe file contains what? Linux OS library. Linux OS library. That's it here. Okay. So here exe file prepared on Linux OS. Then it contains binary code for C program, binary code for C library, binary code for OS library. Suppose let us take one more example. One more example. One more example. C++. C++ exe file prepared on Windows OS. Prepared on Windows OS. Prepared on Windows OS. Windows OS. Windows OS. Then it contains binary code for C++ program. Next, plus binary code for C++ library. C++ library is something like std. Sorry, iOS team data cetera file. Binary code for yes, Windows OS library. That is exe file. Binary code for Windows OS library. Windows OS library. Binary code for Windows OS library. This is about exe file. This is about exe file. Okay, so exe file linked with OS library at the time of creation of exe itself. It's a static linking. Okay, exe file. See exe file, exe file, exe file always exe file. Yes, always links with OS library, links with OS library, OS library, OS library. Okay, yes, exe file always links with OS library. It's a static linking. Okay, fine. Now here, suppose for example here, for example, test.exe file. For example, test.exe file, test.exe file prepared on Windows OS, on Windows OS, on Windows OS. Then then it links, then it links, then it links with yes Win library, the Windows library. Okay, yes. Now how this program running on different operations? When you try to run it here, yes. When you try to run it on different operations, how it's working? Let us take different platforms. Okay, let us take different platforms. Now test.exe file working on different platforms. The test.exe file, test.exe file working on, yes, working on different platforms. How? Yes, let us see different platforms, different platforms, different platforms. Let us see. First, let us take Windows platform. Test.exe file and Windows OS. Okay, so test.exe file, test.exe file on Windows OS, on Windows OS. Test.exe file on Windows OS. See, yes, hardware, hardware. Okay, hardware, hardware. Yes, on top of hardware, this is OS. On top of hardware, this is OS. On top of hardware, Windows OS. Windows OS. On top of hardware, Windows with Win library. Windows with Win library. Okay, Windows Win library. Windows with okay, Windows with Windows Win library. Okay, now on top of which now placing test.exe file. Now test.exe file. So test.exe file placing an Windows OS. Test.exe file. Test.exe file. So test.exe file. Okay, so this test.exe file. So this test.exe file, say placed on Windows OS. How it's working here? How it works here? See, when you try to execute test.exe file, when you try to execute test.exe file, yes, it will try to call, yes, it will try to call Windows library. It will try to call Windows library. It will try to call Windows library. It will try to invoke Windows library. Okay, yes, the test.exe file, since test.exe file linked with Windows OS library, it is linked with Windows OS library. See this test.exe file prepared on Windows OS, then it links with Windows OS, links with Windows library. Okay, so now test.exe file working on different platforms. Now on Windows platform. Now when you try to run this test.exe file, it will try to call Windows library, just trying to call Windows library, just trying to call Windows library. Yes, it's available. Calling Windows library, using that library communicate with hardware components. That's it. Program successfully completion here. Program will complete successfully here. Okay, now let us take another platform. Same exe file on another platform. Let us take another platform. Let us take another platform. Another platform. Same test.exe file on another platform. Let us say Linux platform. Test.exe file on Linux platform. Let us take Linux base. Linux with Linux OS library. Linux OS library, Linux OS library. Okay, see when you try to execute test.exe file, now this test.exe file, yes, it is linked with Windows OS library. It will try to call Windows library, but here is not available. That library is not matching. Test.exe file linked with Windows OS library. Since linked with Windows OS library, it will try to call Windows library, but here is not available. So OS changed. That library is not available. Since library is not available, simply it fails. It fails. Let us take another platform, Unix. Suppose Unix platform, Unix with Unix library. Here are the same happened here. Yes, test.exe file. It will try to call Windows library, but it's not available. Again fails. Here are separates. That's it. That's it here. Okay. So that's the reason exe file is OS dependent. See, since exe file linked with OS library. OS library. Yes. OS library, it's an OS dependent. Yes, it's an OS dependent. OS dependent. OS dependent. OS dependent. Okay. OS dependent. OS dependent. OS dependent. That's it here. Okay. See here. Here question. Starting question. Yes. See this. exe file. Yes. exe file prepared in Windows OS. Can I run a Linux OS? No. Okay. Reason exe file is OS dependent. Why exe file is OS dependent? Now we can answer. So why exe file is OS dependent? For this answer, yes, exe file links with exe file links with OS library, OS library. Okay, since exe file contains OS library, yes, it's an OS dependent, OS dependent. That's it. OS dependent. OS dependent. I hope everyone you understand about exe file. Is it clear? Yes, about exe file. So why exe file is OS dependent? I think everyone you understand clearly. Yes, guys. Exe file is OS dependent. Okay, reasons. The topic clearly understand, right? I hope everyone you understand. Okay, that is about exe file concepts. Now let us come to Java. Please respond. If not understanding, you ask me, I will repeat. If not understanding, you ask me, I'll repeat. Okay? Yes. So that is about exe. Now let us come to Java. Yes. Come to Java. Java. Let us say about Java. Yes, what happened Java? Same example. Java. Let us take same example in Java. This is Java. See, Java program. Java program dot class file, not exe file. Dot class file. Dot class file prepared on Windows OS. Prepared on Windows OS. Windows OS, then it contains what? See, Java program dot class file prepared on Windows OS, then it contains binary code, not binary code, it's a byte code. Byte code for Java program. Byte code for Java program. Okay, byte code for Java program. Next, byte code for Java library. Like C language in Java, this library concept here. Byte code for Java library. Byte code for Java library. Next, binary code for Windows OS library. No, only this part. Dot class file don't have any OS library. Okay, see here dot class file contains what? Byte code for Java program, byte code for Java program, and byte code for Java library. See, Java library also developed in Java. Java library also developed in Java. That means dot class file is a pure Java program. Yes, yes. Dot class file don't have any OS library. Dot class file don't have any OS library. Okay, any OS library, any OS library. Okay, yes, it's a free. It is free from OS library. It is free. It is free from OS library. It's free from OS library. Don't have any OS library. Okay, yes, it's a pure Java program. It's a pure Java program. Java program. It's a pure Java program in byte format. In byte format. That's it. So dot class file don't have any OS library. See here byte code for Java program and byte code for Java library. That's it. So dot class file don't have any OS library. Yes, it is free from OS library. It is pure Java program in byte format, byte code format, byte code format. That's it here. Okay. Yes. Suppose, for example, tested dot plus, tested dot plus file prepared, prepared, prepared on anyways. Tested dot plus prepared anyways here. Yes. Prepared anyways. Yes, it don't have. Yes, it don't have. It don't have. Yes, don't have any OS library. Any OS library. No OS library. It's a free from OS library. See, dot class file prepared are anyways, but it don't have any OS library. It don't have any OS library. Okay. Now, how the dot class file is running here? Now, let us say about dot class file. How the dot class file is working? Dot class file working on different platforms. Working on different platforms. Different platforms. Like the exe file dot class file. Let us see different platforms. Okay. Now let us take different platforms. First, Windows platform. First, let us take Windows platform. Windows platform. Windows platform. Okay. So tested dot class file on different platforms. On different platforms. Okay. So tested dot class file. Now tested dot class file placing on Windows base. Test this tested dot class file. Tested dot class file just placing on Windows base. Okay. Not tested dot class file. Tested dot class file. Is it tested dot class? Just a tested dot class file. Yes. Now this tested dot class file can I run directly? Tested dot class file placed here. Can I run? Can I run it? Not tested dot class file. So tested dot class file placed on yes Windows base. Windows base with Windows library. So can I run it? Can I run it here? See, to run any program, that has to link with OS library. See that previous points. Yes, every program has to link with OS library before going to start execution. See, these programs linking with OS library and then communicates with hardware component. It has to link. Even Java program also has to link. Even Java program also has to link. So now this tested dot as well has to link with Windows OS library. Who will link it? Yes. See, this tested dot class file directly cannot run. Tested dot class file, yes, no chance to run. You cannot run directly. Now this tested dot class file has to link with Windows OS library. Who will link it here? Between tested dot class file and Windows OS, one more layer comes. One more layer comes between tested dot class file, Windows OS. Between that, one more layer comes. What is that layer? Anyone can guess it. One more layer comes. So what is that layer? So one more layer comes. One more layer comes between tested dot class file and Windows OS library. Yes, there is one more layer comes. That layer is a JVM, Java Virtual Machine. JDK is different. JVM is different here. JVM just is one part in JDK. JDK is a complete Java software. JDK is a complete Java software. JDK contains Java compiler, JVM, JRE, so many kind of things. JDK, JVM, JRE, the topic next we'll discuss. Now JVM comes to picture. Now JVM taking tested dot class file and links with Windows OS library. So once linked here, it communicates with hardware components. That's it here. So Windows JVM taking tested dot class file, links with Windows OS library. Half linking, then execution, generating output finally. Now let us take another platform, Linux platform. On Linux platform, how it's working? Linux platform, same tested dot class file. Now same tested dot class file placing in Linux platform. Same test dot class file and Linux platform. Yes, Linux with Linux library. Now here also same thing happens. Here also what happens here? Linux. On Linux base, this is a Linux JVM. Linux JVM taking tested dot class file links with Linux OS library. Once linked with OS library, then communicates with the hardware components. That's it. Okay. So what is happening here? See, if OS is Windows OS, JVM taking test.class for linking with Windows OS library. Suppose if OS is Linux OS, The JVM taking test.class for linking with Linux OS library here. Okay, suppose one more platform, Unix platform. If it is Unix OS, what happens here? On Unix OS also there is JVM here. On Unix OS also there is JVM. One second. On Unix OS also there is JVM. Yes, Unix platform. Yes, here hardware. Hardware. Okay. Yes. Now this is Unix OS. Unix with Unix library. Yes. Here also JVM. Now this Unix JVM taking test.class file links with Unix library. Once linked, then communicates with hardware. That's it here. Yes, even OS changing. Yes, no issue. That link changes. Yes, if OS is Windows OS, JVM links test.class to Windows OS. If OS is Linux OS here, same test.class for now linking to Linux OS. That link changing dynamically. Link is changing dynamically. Okay, so depends on current OS. That link is changing dynamically here. Okay, yes, see here, since Java, yes, since Java program, since Java, yes, since Java program, yes, links with OS library, yes, OS library at runtime, at runtime. Runtime is dynamically linking at runtime. Yes, since Java program links with OS library at runtime, yes, yes, it's an independent of OS. It's an yes, independent of OS. Independent of OS. Okay, now here JVM, yes, here JVM is responsible. Okay, JVM links, dot class, JVM links, dot class file to current OS library. For current OS level. So JVM takes care of that linking here. That's it here. So you get JVM links dot class file with current OS library. Okay. Yes, even OS changing, that link changing automatically. Dynamically linking. Okay. If it is Windows OS, links to Windows OS library. If it is Linux OS, linking to Linux OS library. If it is Unix OS, links to Unix library. That's it. So that's the reason. Yes, Java program for is independent platform. Java program is independent platform. Reason is this. Okay. Now here question is here. JVM, is it part of OS? Yes. JVM, is it part of OS? JVM, is it part of OS? Anyone can you guess it? JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. Yes. JVM should be installed. How to get JVM? JDK. Yes, JDK. JDK software. Once JDK software installed, that getting JVM automatically. Here JDK has to install. So once JDK installed here, yes, getting JVM automatically. Getting JVM automatically. Okay, fine. Next, one more important point here. One more important point. Java program file is an independent platform. The tested dot class file is independent platform, but JVM is a OS dependent. JVM is a OS dependent. JVM is OS dependent. Okay, see here, Java program. See Java program is an independent platform. Is an independent of platform. But JVM is a OS dependent. JVM is an OS dependent. Reason JVM, yes, JVM is a C++ exe file. Yes, it was developed in C++. It was developed in C++. Yes, it's a exe file. If it is exe file, then it's a OS dependent. JVM is a C++ exe file. It was developed in C++. That's it here. C++ based. C++ exe file. C++ exe file. Okay, C++ exe file. Right? So JVM is a C++ exe file. If it is exe file, OS dependent. OS dependent. For Windows OS, yes, one JVM developed. For Linux OS, another JVM. Sunsoft developed different JVMs for different operating systems. Different JVMs for different operating systems. Why different JVMs for different operating systems? To understand OS. To understand OS here. To understand, see this. See here, JVM, Windows JVM having knowledge of Windows OS. Linux JVM is having knowledge of Linux OS. Next, Unix JVM is having knowledge of Unix OS. So that the JVM can understand OS here. So JVM can understand OS. So once understand here, it can link tested.class to that Windows OS library. Okay, now here I'm saying that JVM is having knowledge of that OS. How? How? See, suppose this exe file prepared on Windows OS, right? JVM exe file prepared on Windows OS. That exe file contains what? Tell me now. JVM exe file prepared on Windows OS. That exe file contains what? Windows OS library. Okay, this JVM is already having Windows OS library. JVM is exe file. See, JVM.exe. Yes, this JVM.exe. Yes, this JVM.exe. So it's a .exe file. This .exe file contains what? Windows OS library. Exe file always linking with OS library. So this JVM exe file contains Windows OS library. Next, this JVM exe file already linked with Linux OS library. Yeah, this JVM exe file is already linked with Unix library. So since JVM already linked with OS library, it's having knowledge of OS library. That's it here. Okay. See, Linux JVM is already linked with Linux OS library, so it's having knowledge of Linux OS library. That's it here. Okay, so JVM is a OS dependent. Okay, Sunsoft developed separate JVM for separate operating systems. Windows JVM, okay, links with Windows OS library. Linux JVM links with Linux OS library. Yes, Unix JVM, yes, linking tested.class to Unix library. That's it here. So JVM is a exe file. JVM is OS dependent. Since JVM is OS dependent, JDK also OS dependent. Yes, JVM is a part of JDK. JVM is a part of JDK. Suppose if you downloaded one JDK here, Windows JDK downloaded. For example, Windows JDK. See, this application means exe file, right? Yes, see, JDK for Windows OS. JDK for Windows OS. If you download JDK for Windows OS, can I run on Linux OS? No. No. Reason JDK is OS dependent. Why JDK is OS dependent? JVM is OS dependent. JDK contains one JVM. JDK contains a JVM. That JVM is OS dependent. Since JVM is a OS dependent, JDK also OS dependent. Okay, same JDK you can't install on different operating systems. Suppose Windows JDK downloaded. Can I install Linux OS? No, I can't. Linux JDK or Windows OS cannot. So for different operations, you have to download different JDKs. Yes, I'll show that. Different JDKs. Yes, JDK. Yes, download JDK 1.8. This is 1. JDK 8. See this. Yes, Oracle sites. Java from the Oracle Corporation. Okay. Yes, originally with Sunsoft. Now it is with Oracle Corporation. See. So this is downloads. All the JDK downloads. See, for Windows 64-bit OS. Windows 64-bit. Now our OS. For our Windows 10. Yeah, this JDK we have to download it. Windows 64-bit OS. This should be downloaded. So Windows JDK. This is JDK for Windows OS. JDK for Solaris. JDK for Solaris. Okay. JDK for Mac OS. JDK for Mac OS. JDK for Linux OS. tar.gz. This is Ubuntu Linux. This is JDK for Ubuntu Linux. RPM Red Hat Pack Manager. Sorry, Red Hat Pack Manager. RPM is Red Hat Pack Manager, means this is for Red Hat Linux. Okay, this is for Ubuntu Linux. This is for Red Hat. RPM means Red Hat Pack Manager. Okay, so this is for Red Hat Linux. Okay, like this different Linux operating systems and Windows operating system, Mac OS, Solaris. Depends on OS that Yes, changes, software changes, JDK changes. JDK is a voice dependent. JDK is a voice dependent. Okay, reason Java is voice dependent. That's it here. So this is reason how Java made us independent platform. How Java made us independent platform. Okay, simple answer. Java dot class file is a pure Java program. Don't have any voice library. Java dot class file don't have any voice library. Yes, the Java dot class file links with voice library at runtime. It's a dynamically linking. Dynamically linking. So here since Java program links with voice library is a dynamically it's an independent of voice. That's it here. Behind of this JVM. JVM takes care of linking dynamically with different operations. That's it. This is independent of platform. Yes. You understand guys how Java made us independent platform? Yes. Now what is exe file? What is dot class file? Difference between exe file and dot class file. That points also already prepared. Dot class file exe file differences. See exe file and dot class file difference. See that first 2 points. See exe file. It's a binary code file. It's a system understandable language. Binary code file and system understandable language. System understandable language. What is dot class file? It's a byte code file. It's a byte code file. It's a JVM understandable language. It's a byte code file and JVM understandable language. Okay. Yes. Next. See exe file. It contains program code plus software library plus OS library. Exe file contains program code plus software library plus OS library. A dot class, pure Java program. Don't have any OS library. It contains byte code for Java program and byte code for Java library. It's a purely Java program. Okay. Yes. Next. Exe file is a prepared file for specific operating system. Yes, prepared file. Yes, dot class is not a prepared file. You don't have any voice library. Dot class file is not a prepared file. Dot class file is not a prepared file. You don't have any voice library. Okay. Yes, next. See, voice library. Voice library statically linking with exe file. Voice library statically linking with exe file. Next here, voice library dynamically linking with dot class file at runtime. At runtime. Okay. Yes. See here next exe file. Exe file is already prepared one. Okay, already prepared one before going to execute. Yes, what is dot class? Dot class file is not a prepared one. Dot class is not prepared. After moving on to OS, JVM prepares. That means JVM linking dot class to OS library. It's a preparation. Dot class is not a prepared file. After moving on to OS, JVM prepares as per current OS. Okay. Next, one more point here. See, exe file executes faster than dot class file. Exe file executes faster than dot class file. Reason, exe file is already prepared file. Exe file is a binary code file already prepared for specific OS. So direct execution. Again, runtime preparation not necessary. See dot class file. Since dot class file preparing at runtime. Since dot class file preparing at runtime linking to OS library. So it runs slowly here. It executes preparing and execution. Preparation execution. Since dot class file preparing at runtime, it executes slowly the exe file. That's it here. So this is about difference between exe file dot class file. Exe file dot class. Okay. I hope everyone you understand this is independent platform. Next, one more thing here. See about exe file dot class file. Just to try in Google. Just you guys try in Google. No, you can't get that much of information. Simply only 2 lines of matter. We'll get it here. Okay. See, no trainer will give this much of explanation. Independent platform about exe file knowledge. It's not easy exe file knowledge. Yes, I worked on embedded C also. With that embedded C knowledge only, I'm able to explain about exe file. Embedded C knowledge. Yes, on Linux voice showed, Windows voice. Yes, everything I worked. So because of my experience only here. Okay, I'm sure no Java trainer will explain this topic. Not on this topic, in future also. Next coming topic also, No Java trainer will explain like this. Okay, even no website in the world will give this much of information. See, my experience is more than the all the websites in the world. Okay, see, many they have written books, but I have not written book. That's it. Difference between me and them, just not written book here. Somebody written book, but I have not written any book. Just not. Just I'm working because of busy with my working here. Yes, because of my busy with my working, unable to write book and all these things. That's it here. Okay, so my knowledge is different from others. Okay, see, I worked on Linux base, embedded C, Java, Hadoop. With that various different kind of experience only, I'm able to explain very clearly. That's it. Okay. I think everyone you understand clearly. Yes, guys. Is it clear? Topics. Yes, going forward also same like this on explanation. Day by day increasing interest. Generally, most of the trainer classes day by day decreasing interest, but my classes day by day increasing interest. We'll see going forward. My class are different. My experience is different here. Yes, my way of explanation is different. My document is different. My programming is different here. You'll see something different from others 100%. Okay, extraordinary skills in the programming. Extraordinary skills here. Not only programming, even presentation also I have the good presentation skills. Okay, yes. Yeah, that's all for today. Yes, still any doubts? Still any doubts? Yes, still any doubts? 1 second. Yes, tomorrow 31st December, next 1st Jan and 2nd Jan holidays. Yes, tomorrow 31st, Friday 31st. Okay, Friday 31st. So 31st Friday, 1st Jan Saturday, 2nd Sunday. So these three classes don't have. These 3 days don't have the classes. Next class Monday. Next class next year. Today is the last class in this year. Today is a last class in the year. Next class in the next year. Next class will be in the next year. Okay. Yes. We will meet in the next year. We will meet in the next year. You all guys, advance happy new year to all of guys. Advance happy new year. Celebrate 3 days. Enjoy well and start new career, new life in the new year. Okay. Yes, new career and new life. Okay. I hope, yes, but I hope better for, yes, new year, better in the new year, definitely. Okay, yeah, that's all. So thank you guys. Yes, see you on Monday. Thank you all of you.